Good afternoon, it's Jeremy. It's Thursday, April the 21st. And today what I'd like to do is look at using the HRF1, this little guy here. This is a software-defined radio. It works from 1 megahertz up to 6 gigahertz. So we're going to look at using this as a signal source or a signal generator for amateur radio use. Now, in the past 20 years, I've worked on and built quite a few software-defined radios. And what I've used as a test instrument is this guy here. And I built this using an Analog Devices DTS chip. I think it was the 9250, something like that. The correct number's in the blog post. But I put this together about 20 years ago. It's pretty solid. It works up to 25 megahertz. It's got a battery. It's kind of heavy, but it's got a metal case. It's rugged. You can sit on it and take it out into the field. But I was talking to a ham, excuse me, I was talking to a ham last week, a fellow ham, and he's using this guy in one of his projects, which I thought, wow, that's pretty good. I've had this for 4 years, and I rarely used it. I only used it on reception. It's got a good sampling rate. It can go up to 10 megasamples per second, and if you push it, if your USB is fast enough, it'll go up to 20 megasamples per second. But I used it receiving ADSB packets. And with a wider sampling range, I was able to get a much clearer packet decode. If you use the RTL, it goes up to 2.4 megasamples per second. So you can get a much better definition of a packet with this guy. So I was kind of interested to use this as a signal source. So basically the way I've got it connected up here is I'm using the output here. I'm taking it here. The output serves as receive and transmit. And it's half duplex, so you can't do both at the same time. And it's going into a 10 dB pad and a DC block. Now, I'm a paranoid schizophrenic when it comes to spectrum analyzers because they're very expensive, and you've only got one front-end LNA, so I always put in a pad no matter what. And a DC block in case you're looking at an RF circuit which has got a bias on it. So that's my spectrum analyzer. It's the Signal Hound, and I'm running Spike software to go with this. So let's go into Camtasia and we'll look at the screens. Okay, so to control the HRF1, there's two methods I came up with. The first method is basically just using a GNU radio. So there's my GNU radio companion. It's a very simple schematic. I'm using the Osmocom sync, and it'll find your HackRF if you plug it in. And basically I've got two range variables. The first range variable is for the frequency. So I've set this up for the 20 meter band. Default value is 14.2 megs. And it goes from, let's say, 14 megs up to 14.25 in 10K steps. You can adjust this as you wish. So you put that in as a range variable called freq. And then here I've set up the RF gain. And it'll go from 0 to 47. And if you go here to the slider controls, there's my IF gain. So I've got it set up at the full gain. And then on the Spike software here, I've got a preset reference level of 10 dB. So that it takes account for the pad. So I'm showing the true receive levels here. So I'm showing about minus 20 dBm at 14.2 megahertz. That's a perfect level for doing signal testing. You can't use this as a transmitter, but for a signal generator to test a receiver, this is an ideal signal level of minus 20 dBm. Okay, so let's turn off the GNU radio. Incidentally, all the setup for the GNU radio is on my blog post. So let's turn that off and we'll go into SDR Angel. That's another way of controlling. When you start SDR Angel, you have, let's just close this presets. You'll have a default R0, which is a receive device set. So set that up for a local file input. That'll be fine. You don't want to select the HRF1 on the R0 because it's half duplex and you won't be able to use it on transmit. So now we'll add a sync device. Okay, now we'll select the HRF1. So we'll find it here from the pull down list. So there it is there. Okay, now I'm going to add a channel module. And we can use several channel modules, but the narrowband FM seems to work pretty well. We're not actually going to do any FM modulation. If you wanted to, you would press this button, but we don't have to. So let's crank this gain up to 47 like we did before, and we just have to start this. There we go. We see a red line, which means it's transmitting, and we should see it on spike. Oh yeah, I have to adjust the frequency here. I'm at 435. Let me go down to 14.2. This is just like a real signal generator. That's the nice thing about SDR Angel. If you're used to, flipping dials like this, you'll feel very comfortable with this method. So there we go. There's my 14.2. It's about 1 dB weaker than using GNU Radio, but you do have the nice interface here. It's a lot easier to use than I don't know. It just looks like a standard frequency generator. So basically, we've seen two ways of controlling the HRF1. If you've got Linux, you can also use the HRF1 transfer command with the various options. That's another way of enabling the signal generator.